Question 8, you're asked to determine the acceleration of free fall at the surface of G. This is an experiment that would have been done in class, and you were using your smartphone with a slow motion camera app, and you were using a ball and a ruler attached to a clamp stand. So that's the experiment that was done to calculate the acceleration of free fall. So without a falling object, without a distance measurement device, and a time measurement device, which is already included in the question, you can't work out the value for G. So both of these are required for the mark. Now, explain how you would find the time for the object to fall. So time taken. How would you use your video capture app, the slow motion camera app, to determine the time taken? So you're using the slow motion camera app. Okay, so you're going to start the recording before you drop the ball, not at the point where you drop the ball, because that's going to include more uncertainty. So start the video recording before the ball is dropped. Stop the video after the ball hits the ground, not when it hits the ground, because the slow motion camera app, you can go back in time to see exactly when the release point was and the exact point where the ball hit the ground. So what do we need to find the time taken for the object to fall? So take the release time from the time on your smartphone, take the time the ball hits the ground, and subtract them to find the time of the fall. Now, it's quite obvious what we need to do, but we need to mention it step by step. Take the initial time, point of release, take the final time, point the ball hit the ground, subtract the two, and there's your two marks. Okay, explain how you'd use the measurements of to find G. So you've just got time from the slow motion camera app. The ruler will enable you to get a distance. So method in part 2 for getting the time, distance of fall using a ruler. From that you can work out average speed. Write down how to work out average speed. Okay, you need to say exactly how you do it. It's an explain. So it's total distance divided by time. Then to find the acceleration, we need to have final speed, initial speed. So this here is average speed. So we know that the speed is increasing during the fall. So as the ball falls, it increases speed. So double the average speed to find the final speed. That statement needs to be in there. Then using acceleration is final speed minus initial speed. Final speed we just found. Initial speed, we know it's at rest, so it's 0. And the time taken, that's from the method that we figured out earlier. And do the calculation and you'll find the acceleration. Or when we put all of these formulas together, we actually get the acceleration is equal to 2 times the height over the time it took for the object to fall squared. And this was a derivation that was done in class. So that's a quick jump and you get to the answer straight away, or you have to mention all three at the same time. So give one precaution that you would take to ensure the accuracy of the measurements. Okay, so to make this experiment accurate, the ruler needs to be perpendicular to the surface because the object falls vertically. So ensuring the ruler is perpendicular will give you the right height measurements. So the camera that you set up is not too close, and we want to reduce parallax error. So move it so that it's still in focus, and that will reduce parallax error and therefore increase the accuracy. And you're not throwing the ball downwards because we said the initial speed was 0. So ensure that no force is put on the ball initially. This ensures that the initial speed is 0. These are all the things that you could do to improve the accuracy of all of our measurements. Now, repeating the experiment does not ensure that the experiment is accurate. Okay, the if you use an incorrect technique over and over again, you could still be very, very far away from the real value. Okay, so by repeating a bad method or incorrect method and taking an average may not necessarily bring you closer to the final true value. That's what we're trying to get. Accuracy reflects how close you are to the real value of the measurement that you are trying to get to. So 9.81. So you can do an experiment using an incorrect technique, repeat it 3 times incorrectly, get an average, and it'll still be quite far away from the real value. Okay, so in that respect, repeating reduces random error but does not reduce a systematic error. Question 9. Explain the difference between a scalar and vector quantities. This is a definition from GCSE also. Scalar is a value with no direction, magnitude only. Vector has a size, value, and a direction associated with it. This question here, when asked to run one complete lap around the track, a student says, however fast I run, my average velocity for the lap will be 0. Okay, note what it says in the question. Average velocity. Velocity is a vector. Okay, so therefore, when we look at the formula, it is not just distance over time. When we look at the formula, it should be displacement over time. So if this said average speed, then we will say it's distance divided by time. If it says average velocity, this is displacement divided by time. So displacement divided by time, vector here, vector here. So there's a difference between the formula. So velocity is displacement over time, whereas speed is distance over time. So when they say that however fast you run, the average velocity will be 0. Now, let's look at the formula. Displacement, if you start and finish, if you do one complete lap around the track, you'll start and finish in the same place. So when you start and finish in the same place, your displacement is 0, because the definition of displacement is the direct distance from the starting point till the end point. So if the distance from the start till the end point, the direct distance is 0, so therefore the displacement is 0. So that means that if you put 0 at the top here, the velocity will end up being 0 as well. So the average velocity is equal to 0, and therefore the student is correct. If you were to look at speed, average speed, then that statement will be incorrect, because when you go around the track, let's say 400 meters around the track, that would then be 400 meters as a distance, and then that would have been timed, so there would be a finite time, and then therefore the speed would change because the timing would have changed, the distance would have stayed the same. So displacement is the direct distance from start to finish, and if the starting and finishing point are in the same place, the displacement is 0. Question 10. You've got a battery rolling down an inclined plane, and some points of this battery are marked. So looking plan view, there's your start position. Every second that it says here, that's where the battery's position was: there, and there. Okay. Now what you see underneath is I've taken all of this from this table. Okay. So these are the answers, but before we look at the answers, let's have a look at the time. So going from 1 second, 2 second, 3 second, 4 second, because every point marked here is each second along. Okay, so it says that the distance from the start position, and these are the respective distances. And what I've done, I've gone through drew them on there. So after 1 second, you've traveled 0.18 meters from the starting point. After 2 seconds, 0.84 meters from the starting point. 3 seconds is 1.7 meters from the start, 75 meters from the starting point. 4 seconds is 3.14 meters from the starting point. So that's what I've put up. Then I look at the last column first. Average velocity from the start. So average velocity is the displacement from start to that point over the time taken. So after 1 second, we know that the distance traveled is 0.18 divided by 1 second. So our velocity would have been 0.18. And the distance here traveled is 0.84 divided by 2 seconds, 0.41, and 1.75 divided by 3 seconds, which is 0.58, and 3.14 divided by 4 is 0.79. The next column is average velocity in the previous second. Okay, so let's have a look. So 3.14 is the distance traveled in 4 seconds. 1.75 is the distance traveled in 3 seconds. So the distance traveled in the previous second to go from there to there, that distance there, is just the difference between this and this. So that's the distance. Remember, to get velocity, we know we need distance. So in the previous second, that distance is 1.39 meters. Okay. How long did it take to go from there to there? It was 1 second, because we can see that it was 3 seconds, and then 4 seconds it was in this position. So the average speed in the previous second, in this second here, is 1.39 meters per second. Okay. And that's what's written here. Now, the distance traveled in the previous second from 3 seconds to 2 seconds. Again, we look at the difference in distances. Visually, it's easier. And that's 0.191 meters from there to there. How long did it take to go from there to there? It was 1 second to go from here to here. 2 seconds, and then 3 seconds, the object was there. So they traveled 0.91 meters in 1 second, so therefore the speed is 0.91 meters per second. Okay, so at 2 seconds, okay, the previous second, so from 1 second to 2 seconds, the distance traveled was 0.66 meters, the difference between 0.84 and 0.18, and that was traveled in 1 second. So that was 0.66 meters per second. Right. It says justify which of the columns, A or B, gives a more accurate value for the velocity of the battery at the bottom of the inclined board. Now, let's have a look. What does this show us? This shows us average velocity from the start. We know that the average velocity is actually not the velocity at the end. Okay, so when we worked out the average velocity using this total distance and the time taken, we've actually worked out the velocity in the middle somewhere. That is the velocity somewhere halfway. To find the final velocity, we just double it. Okay, but that's not the question. So the actual average velocity shows the speed of the battery midpoint here. Okay, but when we look at the velocity in the last second. So from here to here, let's say. Okay, so at the bottom, if you look at it, the question is justify which column A or B gives more accurate value for the velocity of the battery at the bottom of the inclined board. So I'm looking at this at the bottom on it. Because these two values 0.79, 1.39, which one's more accurate? So 0.79 is the actual velocity halfway through, because we've taken the total distance divided by time, that's somewhere here. So we've got the speed halfway. On average, because be less than that value and more than that value for the same duration in time. For the last second, we know that the average speed in this section here was 1.39 meters per second. So that's actually the speed halfway here. And that there is somewhere there. So what we've got, 1.39 meters per second is the speed here, which is actually closer to the bottom. So that there is a more of a reflective speed, closer to the bottom of this inclined board compared to the speed, average speed that signified the midpoint here. Okay, so B gives us midpoint here, A gives us a midpoint somewhere around here. So which one is better reflection? A. So how have I written that? A, because the average velocity from the start gives a speed at 1.57 meters along the slope. I've just done half of the total distance. And but the average speed in the previous second gives a speed halfway between 3.14 meters and 1.75 meters, which is closer to the bottom.